Okay, so like I said, your Python teacher is not available today, so I'm covering for him. And so first of all, is there any question from what you've done so far? Um, Variables, loops, I believe that's the last thing you did. And like I said, you have to do exercises. That's really the only way you can really learn. And one thing about learning like this is that you don't even have any reason why you should not be able to do the exercises. Because if you have any question, we're open to receiving those questions and explaining those concepts more. So you have to ask questions where you have questions so that you can really understand what we're doing. Okay, so don't wait till you say, okay, maybe, like I said, it's not like you have to get to wait till it's time for exam before you start studying. No, this is not the kind of thing we're doing here. So you need to take advantage of every section you're learning, everything you're learning here. It's very, very important. Okay, so especially like in this Python, I encourage you guys to really take it seriously because there are a lot of opportunities out there. When we talk of something like data science and AI, AI, for instance, has not even really started in Africa. It's yet to start. So, and even if it starts now, you realize that you don't have enough people with the kind of skill that is needed to push it through. So we're at the beginning of something big, and let it be that by the time it's the momentum starts, and then the momentum will start soon, that will start moving. And so let it be that you have all what it takes to be part of it. And that's why we're learning this now. So that time, because at that time now, you now see that, oh, this is now really happening in Africa. And you now see, by that time, maybe you will not be able to learn again. But by now, for now, that it's even yet to start. So it's good that we gain this skill. And even in Europe, all right, the momentum is there, but there's still a lot of things that have not been done. There's still a lot of opportunities in Europe, in America. Right now in the AI race, I think America is leading in terms of research, but in terms of adoption, China is leading. And Europe is on the third place. So, you see, of course, fourth place should be somewhere, maybe some Asian countries, and then before you talk of Africa, which we've not even started. So this learning a skill like this presents opportunity for us, a huge opportunity for us to, or we can say endless opportunities for us to really be part of what's going on. Okay, but you can only take advantage of this by doing the actual learning. Okay, that's the thing. So if you're not doing the assignment, you're just occupying space. That's what it means. You're just so it's important that we do the assignments so that we can pass. The thing is that one thing about learning things, something like once you've learned it and mastered, you've passed that level. You move on to something else. Okay, or if you remain at the same level for a long time, then to be discouraging. All right. So anyway, so like what we're going to do today, we'll just look at because it seems that none of you have a question. So we'll just look at let's see. So let me share my screen. I believe I can share my screen. All right, sorry guys, it seems that I went off for a moment. Okay, so I think I can share my screen now. So let me share my entire screen. All right. Let me know if you can see my screen. I think I can close this.
Yes.
Okay. All right. Let's see. Let's find right. Developer coding. Nope. Documents. Sorry. Okay. Okay. So I'm gonna open this. So this is. Have you all seen this question before now? Hello.
No.
Which means you've not started looking at the. This is the last question on chapter in chapter 2. So I thought that's maybe something that one of you must have tried it to solve. But that's what I want us to look at today. Okay, so because actually you're supposed to start chapter 3 today, but if you have not done the exercise, there's really no need to start chapter 3. If you've not done the exercise, if none of you have done the exercises. Okay, so this, so we're going to just take a look at this problem. This problem we're going to learn how to solve computational problems. Okay, I'm going to learn some of the skills that are needed to solve computational problems. What we do as programmers is basically we solve problems computationally. Okay, and of course, when you learn how to solve a problem, the skill is transferable. It doesn't have to be a computational problem, but the same framework you use to solve computational problem, you can also apply to solving real world like problems or even social problems. Okay, so let's take a look at this question. So it says, so it says I should write a program that prints a giant letter A, like the one below. Okay, allow the user to specify how large the letter should be. Okay, so this is what you want to describe to the computer how to do it. Because programming is just basically you telling computer what to do. Okay, so how do you tell a computer to print out something like this if the user specify the height of the letter? So if the user specify like 5, like in this case, it seems like the 1, 2, 3, 4, 5. So it seems like the height is 5. So how about when the user specify height like say 30? So how will you print that? Of course, it's going to be one program that accepts different heights, and according to the heights that you accept, it says it's going to print the corresponding letter, okay, of that height, the letter that corresponds to that height, okay. So when you look at a problem like this, okay, the first thing in problem solving is to try to understand the problem, okay. So try to understand the problem. That process we call it problem specification. So you want to specify the problem that once someone sees your specification, like problems usually come in a way that may not be very, very clear. Sometimes even very, very ambiguous. Okay, but for you to be able to describe how to solve the problem to a computer, you need to understand the problem without any ambiguity. Okay, so what do you think we should do when we want to print? Of course, we know how to print our star. Okay, like this. I believe we already know how to do that. So let me see what we can do here. I think I can open the folder. Let's see. Just open a new folder. Of course, the first thing you have to do when you want to solve a computational problem is not to open the Visual Studio first. Okay, so the first thing is for you to really try to understand the problem. Okay, and what we're going to do to understand the problem, and what I'm going to do is let me do something here. So I'm going to open, make use of Google Jamboard. Let's see, whiteboard. So please confirm if you're able to see my screen. Gonna start a new Jamboard. Allow. Continue. So can you see this empty page?
Yes.
Okay.
Yes.
Fantastic. So usually, so take note of this process. So you have a problem you want to solve. Okay. So let me just do this. It's on the right. Put it on the left. Okay. So you have a problem you want to solve. So you need to go through the problem and try to really understand what it is. Okay. So that's the only way you can solve it. So because if you jump in to just solve the problem without understanding it, you're going to waste your time. And in most cases, but in most cases, you will not get it right. Okay. So the first thing you're going to do is to take a look at it and say, okay, they said write a program that prints. Let me see if I can increase this a bit. Okay. All right. So a bit. Okay, this is good. So it's a write a program that prints a giant letter A, like a high. So what they just want you to do is that you write a program that the program will ask the user to specify a height. If the user specifies 5, you're going to print exactly what you have here. Or you can say 1, 2, 3, 4, 5. So how do I know that is it? First of all, I've read this. I know that it's going to print. Then it's stated here. Okay, but then you have to look at the example very well that I'm given to you. So you see, you ask yourself, what is really problem solving? What is computational problem solving? What's it about? What's it all about? Or even any problem, if you are asked to solve a problem. Now, every computation has, so let's take a look at this. I'm just going to draw this. Okay, so every computational problem will have is you have the input. Okay. You have the output. So this is the expected output, of course. So whenever you're given a problem, you're going to see these two things. Okay. But there's no way you're going to be able to solve a problem that you don't know what you expect to be the result of the problem, right? So here, you in most problem, right, you already know the result. You already have an idea of what the result should look like. Okay. Of course, you give it input, which is this. In this case, you said the input is just the height. So when you give it height, the output should be this. So here is where you're going to perform the computation. So the computational process is basically how you'll be able to transform the given input into the expected output. Okay, and this is basically for most 99% of computational problem you're going to be solving. Okay, you're going to just be transforming some input to output. Sorry, instead of the. So this is just what I mean. Yeah, it's computation. Okay. So how do you take input? And I used to, solving computational problems, solving a problem is like making a meal. All right. So in the process of making a meal, let's say you want to make a particular soup. Okay, you're going to get some inputs. The inputs, and the input you get would depend. The output will determine the kind of input you get. Okay. So if you want a particular soup A, okay, you need certain input to be able to achieve that soup. Okay. If you need a different type of soup B, there might be some variation in the inputs. Okay, to be able to achieve that. But you have to know the exact output before you start solving the problem. and then you have to look for the inputs. Okay, so in this case, for instance, in the case of cooking a meal, right, input is something like salt, pepper, onions, all of that. Okay, and then you have to take all this input and transform the input by cooking it and putting the appropriate portion of a different input to be able to get the output. And it's just the same way when you're solving a problem. Okay, so in this case, our input is given. They say that the input is just the height. So they're going to present us with the height. All right, and then the user, the output is going to be the A. Okay, which depends on the height. Okay, but we have to do something here, which is where the computational thinking comes in. How do you transform this input that you're given, which is just height, to something like this? Okay, so is this clear? So these are the three main components of a computational problem. Okay, so when you're looking at a problem set like this, the description, you need to be able to identify the input. Okay, and then they identify the output. Then you now start thinking of how do I, based on what I already know, how do I take this input and transform to this output? That is where the problem, computational thinking comes. Okay, so let's now that we know that it's height, and then the input is this letter A. Okay, so let's look at the example very well, so that, because we need to understand it. So first, what is A? What does, when you say the giant letter A, what does that mean? Okay, so if you look at this, like, means that A is like a line like that, goes like this. One like that, another one comes like this. Now, you may take this for granted that you know what A is, but when you're solving this problem, you now begin to understand that most of the things you take for granted, you don't really understand them. Just know that, oh, when you see a picture, just A. When they say describe A, okay, because if you cannot describe A, the computer will not be, you will not be able to write a program that will print at A, because the result of the program is your description of A, okay, in a way that the computer will understand. Okay, so an A is a line that goes like this. Okay, and then another one that comes like this, and then another one goes like this. That's A. Now, it may seem so simple, but there are a lot of things that are going on here. So a line comes like this. What does that mean? One thing, if you look at it, you observe something that, as in, you're drawing this line, there's this line going slanting like this. There's a space here that is increasing. Okay, so you need to tell the computer that this is what it is. Otherwise, the computer can just draw a straight line. Okay, so you can see this space now. There is space, and then there's also another space that is, this one is increasing up, or let's just say it's decreasing. Okay, so let's say we start from here and then decrease. Okay, so this space now decreases, space between here and the end here. Okay, while the one, there's a space here in the middle that increases, like this space here. Okay, why this one is decreasing, this one's increasing and expanding. Okay, so if you have to understand that this is what it is, because what are you trying to do here? You want to explain to the computer. That is the competition. That's programming. Programming is you describing to a computer what to do or how to do something. Okay, so if you want to draw an A, imagine you have a 2 or 3-year-old boy and want to explain how to draw A. That's how you should explain to a computer. Okay, so you have to be very, very clear. You have to really understand. So it gives you a different type of thinking, computational problem solving. So when you become a programmer, you see that your thinking will change in a certain way. Okay, so things that maybe you have been taking for granted, now you now realize that you need to put some thought. Okay, because you have to be able to explain the thing to someone or to a computer. Okay. Okay, so these are the things we noticed. All right. Now, if we look at this again, let's go back to here. You see that now the star that are being printed here, this star, right? That is 1, 2, 3, 4, 5. Okay, so if I draw a line vertically like this, okay, there's something you notice. If you draw a line like this, you notice that this space is here, so it's increasing by 1 unit. Okay, how do I know that? Okay, so let's start from here down. Let's start from the middle here down. So what's the distance between here and here? How many stars? You see that it's 3 from here. 3. So which means the space here is also 3. Okay, so which means if we increase this size, if you decrease this space by 1 unit, okay, we'll eventually be able to draw this. That means I need to print out 1 star, decrease the space by 1 unit, and go to the next line. Because this one now, if I don't decrease the space now, the next one will be directly up under this. Okay, but for me to have it like this, I need to decrease the space by 1 unit and print out that one on the next line. Decrease the space by 1 unit and print out this on the next line. Decrease the space by 1 unit and print out this until I get to the end. Okay, so is that clear?
Yes.
Okay, all right, so you guys are still here. That's fine. So yeah, so see, that's by 1 unit. Now let's look at this one inside here, the space again here inside. Okay. So this is how you analyze the problem. Okay, so that once you analyze the problem, you take your time to analyze the problem, you understand it, and you give a solution quickly. Okay, but if you just jump on it without understanding it, you get stuck. Okay, and you'll be discouraged. Okay, so now let's look at this one. We already understood that this space is just decreasing by 1 unit. Okay, as we go down, that's what we give, right? So this is just you printing out a star, but this star you are printing now. It just the only why it's slanted like this, because when you print out the first one, you move to the next line or decrease the space between the end and there by 1 unit before you print. That's just what gave rise to that. Okay, so that's how I see this. Now let's look at this middle one now. So you see that the space is increasing. Now, this is a bit tricky. Now, this one's a bit tricky. Now, if we had to fill in this here, this space here, this first space here, how many star are we supposed? How many star can we put here? It's just 1. If you take a look at it, okay, you can see if we put 1 directly here, see just 1 star. But then the next line has 3 stars. See that? So the next line, if we count this now, if you count this space now, how many spaces do you have here? I see 1, 2, 3, 4, 5. So if we have to fill in this with star, we're going to be 5 stars. If we have to fill in this with star, we're going to be 9 stars. So again, you see here, let's go back here. You have the space. The space decreases by, let's say, spaces. Sorry, because I'm writing with my mouse. So spaces decrease by 1 unit. So 1 unit. So that's simple. Okay, this one is simple because 1 unit. Now, this other one now that space is increasing, it's no longer like increasing by 1, 2, 3, 4, but rather it's increasing by 1, 3, 5, 7. So can you tell me what that means? If I have this kind of numbers, 1, the next one is 5. So what sequence of numbers are this?
Odd.
Exactly. So this, yeah. So the space here increases by odd number size, right? So odd numbers are why this one decreased by 1 unit. Okay, why this one is increasing by odd number, this one is increasing by 1 unit. Now, so what all I just need to do now is to print out this. All right, print out that one. Now, for me to print out this now, I need the space here has to be 1 unit of odd number. Okay, 1 odd number unit, which is in this case the first one is 1. The space here is 3. Then the space here is going to be 5, and it's just odd number increment. Okay, odd number increment. Now, there's still something here. Okay, so why this one is just 1? This one just easy, just 1, 1, 1. Yeah. Now, there's another thing. How about this line here? When do we put this line? The horizontal line. So if you look at it very well, very well, you realize that you put this line when you've gone to half of the length. You just fill in the space. So instead of filling empty space like this, you fill in the star when you get to the half of it. So do you understand this explanation? So this is when you have to get to height of half of the height. Instead of having empty spaces, just fill in with star. Do you understand?
Yeah.
Hello?
Yes. Yes.
Okay. So now we can move on to solving the problem. So this is the process you have to always take, when you want to analyze a problem set and you want to come up with a solution. Okay. So if you commit this step, you're going to struggle to solve most problems. In fact, when you're solving some, even although we are not going to probably do much of that here now, maybe later on, if for those that want to go and do data science, right, or want to learn some AI stuff. Okay, so in that case now we have to actually, when you are given a problem, you have to transform this problem to mathematics, really. Okay, so a mathematical description of a kind of what we call first order logic description of problems. Okay, so when you have a first order logic description of problem mathematically, you see that it will be easier for you to just look at the problem and understand it. Okay, like any mathematician will look at the problem and understand exactly what the problem is, and then anybody can look at the mathematical description of the problem and then write the code that will solve the problem. Okay, but we're not going to go deeper into that because we need all these a lot of mathematical concept to be able to do that. But here, at least this kind of, we go to a bit between, like if you are doing back end, you don't need any of those. If you just want to do like back end development, or maybe data analysis, you don't need any of those advanced mathematical concepts. Yeah, but you should be able to know the simple mathematics like odd numbers, even numbers, addition, subtraction, and all of that. Okay, you can see it just all the mathematics you're going to be doing in this programming, this code basically. It's not more than what you did in your JS1 or JS2. Okay, so it's really nothing. But for you, it's just the major task now for you also to be able to understand the problem and transform it to the output. Okay, so let's now move on back to our Visual Studio Code. Okay, so now that we have, so let me just create a file here. I call it big a.py. Okay, I'm sure you know how to create a Python file, so it must end with .py. Okay, so now that we have, I think it will make sense for us to put this side by side. So let me see if I can put this side by side with the so let's see, and just exit full screen and moving to the right, and then where is our no. So I'm just let's move this to the right. What's happening here? Okay. Okay, so we have this is in a different screen. Let me just see if I can adjust this. See the full screen. Move to the right. And okay, so okay. So just copy. So just maybe I'll just copy this. It's not working. Okay, so all right. So let us go on to solve the problem. Okay, so the first thing, of course, is the input. You need to get the input from the user so that you can get. Okay, so I'll write a comment. One of you asked about comment in HTML, but this is also a comment. So in this Python, okay, so get. Let me just increase the size. Get input. I don't need this space here. Get input from user. So that's the first thing. Okay, in this case, it's the height. Height. So get the height from user. You can just tell the user enter, So here I'm going to say how large, how high do you want your A? Okay, so how high do you want your A? So because that's what we're doing here. Now, when you get this, when you get information from a user like this, okay, using this, okay, the information comes as a string. So you need to evaluate it to a number because we want a number. So we're going to do eval. I'm sure you guys have been introduced to this. Okay. Or we can do it on a second line if it's confusing. Let me just do it on a second line. So the first thing is that we get in as a string, which is just a character with quotes. So we need to convert it to a number by doing this eval. And whatever you have in the height. Okay, so this will convert this height to a number, actual number. So the first thing we need to do, just like we have here, see, okay, like we have here. So we're going to just take this. So if you look at this, okay, so the first thing we need to do here is to print out the top and then print out this line like this. Okay, so we'll print out the top. Now, to print out the top, we're going to do print. We're going to create the space first. Okay, we're going to create some space. Now, this space we're going to create, I mean, what we're going to do to be able to control the space and decrease by 1, we can just create a space that is equivalent to the length. That is, we want to create a space that is equivalent to this length, that this space here from the beginning to this point. We want to create a space that is so that once we put it here, we now decrease the length, the height by 1, and then put the next star here. So that's the first thing I'm going to do by multiplying this space by height. Okay, once I multiply this space by height, then I can print the top of the A. So the top of the A like this. Okay, let's see what it looks like. So I'm just going to run it. Save. Just use this here. So I'll just say Python 3. Okay, yeah, it may not be Python 3, or it may just be Python because I'm using a Mac here. So that's why I'm using Python 3. Or if you're using just Windows, you may not need to put the 3. Okay. So I'll just put Python and the big A. So you say how high do you want your A to be? I'll say 5. Okay, so you see it gives this space here because this space I said 5 times this space and then print out this. Okay, so let's move on. Let me just close this one to have space. Okay, now that is this space. Now multiply this by half so that instead of printing it, okay, let me just remove this height. Okay, and then do that again. So you're going to see that the space will just be very close. It will be just one space. So let's go. So if I do this again, I say enter. See, this is now closer because I've removed, I don't multiply by that, I've just one space. Okay. So that is why I'm multiplying by this. Again, this is to help me control that space. Okay, I can multiply by anything. So I can multiply by 10, I can multiply by 20, I can multiply by 20, right? Of course, it's going to give me more space. Even if I put 5, right, it's going to still be 20. You can see it goes all of this 20. But I want it to be I want it to correspond to the height. That's why I'm just multiplying by that same height. Okay. So what we're going to do here is just replace by height. Okay. Then we print out this. So the next thing after I've printed the top, the next thing we need to do is to print out the next one here. That is one. And to do that, I just need to do something like a print height again, one space times height minus 1. Okay, so I'm just going to put this parentheses so that I know that it's together. And then the next one. Okay, so that's the next one. Then let's do this first for maybe like all of them up to height to let's do this. Let's print out for the next one. Okay, so 2, 3, 4, and maybe let's do another one, 5. Okay, 5. So I'm decreasing their space as I move on, and then printing this. So let's see what it looks like if I run this and end up 5. See, so I have all of that, see, I have all of that 1, 2, 3, 4, 5, and then it decreases because I decrease this step, this space here, and I'm printing it in. So the whole thing is just basically the same, just printing the same report, just decreasing the space before you print out this. Okay. Now, of course, this is not sustainable, because what happens if I have to, if I'm giving 50, height to be 50, am I going to keep on doing this 50 times? It doesn't make sense. That's why we have the loop repetition, because this is already a repetition. Okay, the only thing that's changing here is just these numbers. So these are the numbers that are changing. Okay, so but the whole thing is just a repetition. So instead of doing this like this, of course, this first one can still even be part of it. Okay, but I'm just going to leave it outside. Okay, well, this is equivalent to height minus 0. Okay, but I'm not going to consider that one differently for now. Okay, and so I need to repeat this. Okay, so because the user may enter 50 or 60 or 70, so I don't have to start writing this every line like 70 lines. It doesn't make sense. So what we're going to do here instead is we're going to use a loop. Okay, and this is how it works. So for I in range height. Now, because I've already done the first one, so I'll start from 1, then height. Okay, so in computer science, a program, we usually start from 0. So this is 0, but so now this is like the second one now. But these values will take value from 1 up to height, but not including the height. So if I have range like this, range, the values will be 1, 2, 3, 4, up to height minus 1, but not including height. Okay. Height minus 1. So if I have height to be 5, so it will be 1 to 4. Okay, if I had height to be 100, to be 1 to 99. So if I put 0 here, it will be from 0 to height minus 1. Okay, but because I've already handled 1 here, so I just have to like start from 0, 1 here. Okay, so I'm not saying that from that. Check the time. Okay, don't have much time, but okay. For I need range height. Okay, so let's now print out what we did before. So I'll just print out the height again. It's just basically the same thing times height. But this time minus I, because the I now takes those values from 1 to 4. Okay. And then again I print out this star. Okay, so let's take a look at what we have here. So it's exactly just the same thing. So instead of having all those lines, I'm not compressing and putting the loop, just telling the loop to repeat and change only the word this value I, which is now the value that is 1, 2, 3, 4 up to height minus 1. Okay, so let's see if we get the same answer if we do that. So 2, 5 again, exactly the same thing. In fact, let me do like 30 and see 30. Yeah, see that? Just the same thing. Okay, so we're almost getting the see. We've now gotten this. Now, how do we now get this word hours? We need to increase the space somehow by odd numbers before we now print out the right hand side. So let's see how that we can do that one. And of course, it's very simple. Okay, so after printing this one, okay, I need to just print out some space, and the space obviously is space like this, just space. But this time, instead of multiplying by height minus 1, I'll multiply by this. I'll do a small trick here, which is 2. I'm sure some of you will understand this. Minus 1. I mean, this is how you present odd numbers if you're starting from, say, so odd number, there are two ways to present odd numbers from what we learn in primary school or secondary school. So how to represent, let me just quickly just remind. So if you have odd number, right? So if the odd number start from, how do you define odd number? So basically, you have two, okay, let's say even number 0, 1, 2, 3, 4. Let's say have these natural numbers, right? I want to get odd numbers. The odd numbers, if you call this I, or let's say N, okay, that's natural numbers, right? So if you want to get the odd numbers is basically just 2N plus 1 or 2N minus 1. So who can tell me in what case we use, why do we have these two? In what case do we use them? Who can tell me, please? Is anyone here?
Yeah.
So does anyone know why? Are you familiar with these two terms, this one and this one? Yeah, for odd numbers.
Yeah.
Okay, so who can tell me when this is applicable, or why do we have the two, or when should we apply each of this?
First one is applied when you are increasing. The second when you are decreasing or something. When you are flipping your numbers.
Not quite right. Not quite right. So this is how it works, right? The first one is applied if the sequence of numbers start from 0. If you are considering natural numbers, non-negative natural numbers starting from 0. But if you are considering non-negative, if you are considering natural numbers starting from 1, that's when you use this one.
Okay.
Do you understand? Yeah. So in our case now, because we are starting from 1, so that's why we have to use this one. So we have to be very, very clear. We have to really understand why you are choosing a particular thing over the other. Okay. Because we're not starting from 1 up to the height minus 1. We're now using this. Okay. So this is how we're now going to create that space in between. After creating the space, the next thing just to put the asterisks. Okay, so it won't work quite, but let's just see what to get from here. Because this is how you do your stuff. So when you add something, you need to test your program to see if you're online. Okay, if you are really. So let's just try to. I'll clear this again and do this. So this time, let me start with 5. Okay, it's almost there, but okay, there's something that is wrong. Okay, it's almost there because we are not increasing the odd number of times, and then, well, it's not looking quite well. Let me try another number and see. Okay, let me try like 17. See, okay, but man, it's still not, something is wrong. Okay, and let's look at it, why something is wrong here. Okay, so normally how does this work? Okay, if you have two numbers, if you want to print out, okay, let me just show something in Python. I don't know where I work here. Okay, let me just go back first. So I think I'll print it here so that we're sort of going through it different terminal. So typically, if you have in Python, right, if you will print out something in Python, so I'm going to just comment out this just for a moment. So I can show you something about how the print works. So if I have A equals 2, and then have B equals 3, 4, and I have C equals 6. Now, if I print out these numbers, let's print A, comma B, comma C. Now, by default, these numbers, when they show on the screen on the console, they're going to be separated by space. Okay, so let's see. See, so it's print 2, 4 space 2 space 4, and that's got what's called sep here. That by default is equal to a space. Okay, that's what makes this space too. That's what created this space. So if you don't put it, the computer Python just put it there by default. Okay, let's run it again after putting that, so that nothing changes. All right. So what if I now close this space here? and tell it, Python, please close the space. I don't need that space that you give me for free. Okay, you see, it now plays out this. Okay, so what we have done so far here is we do not consider that space created by SEP. Okay, so because we do not consider that space created by SEP, we have to tell Python to close those spaces. Okay, so I'll come here and say, SEP, Python, I don't need any space between the argument that I've given to you here. I don't need this. So I close it. Python, I don't need any space here between the arguments that I've created. I close, therefore I close it. Okay, so I'll do SEP, close. Okay, so I now close. So I don't put, there's no space here. You just put, but no space here. So let's now go back and see what happened. Let's go again. Okay, maybe this one is giving us some. Let's see. Just quickly. Okay, for next, coding colors. Okay, so let's go again. Just increase size. Okay, so let's run this program again and say Python 3 and do 5. Okay, so it's looking good now, looking quite good. So let's do it again and put 30. 30. Oh, fantastic, looking good. Yeah, so the next thing is we still don't have this line here. So that's the next thing we're going to do. Last thing we're going to do. Don't have much time again, but we'll try and just do that quickly. Okay, so we need to be able to create that line. So what we're going to, how we're going to create a line, we tell Python is that Python that when you get to half of this, instead of creating an empty space, just fill it with what? Stars. Okay, the same space, or just fill it with stars instead of filling the space. So how we're going to do that in Python here is, so here we're going to now introduce if statement. So I'll say if I is equal to half of the height. Okay. So do something. I'll say do something here. Otherwise, just do what you've been doing. Okay. So just do, sorry. Let's see. Okay. So one Python to do this, and one Python to do exactly the same thing here, actually. So I'm just going to copy this and put here. The only difference is that, I didn't get that right. Just copy. So I'm just going to copy this and put here. Now, the only difference between these two here is that instead of filling that odd number of spaces now, I'll just tell Python to put a star there. Okay, so instead of filling it when it gets to half of it, so instead of filling with space again, so that it will be voting with empty, instead fill it with this star. Okay, and that is it. That's the end of the program. So let's see now. Fantastic. So we're going to do. All right, so let's start with 3 to even make it smaller. Oh, good, looking good. Let's do 5. Oh, fantastic, it's looking good. Let's do, sorry, just okay, just clear. Now let's do, okay, so let's do 17. Okay, fantastic. Let's do square again, and let's do 30, or maybe 25. I don't know. I don't have enough space. Or 27, let's see. 27. So you see, this is how the problem is solved. We have now solved the problem. And now we can now say that, yes, I've been able to transform the input into the output like this, exactly the way it looks. Okay. So, and it works for any number. So if you have large enough screen and you put like 100 or 105, it's going to show you giant A. Okay. So any question on this? So yeah, it's fantastic knowing how to, like I said, learning computational thinking will make you, really, it's very, very interesting. It's very, very interesting. You're going to think in a certain way. All right, so it's very, very interesting. So please, let's try and okay. So, any question? So we're supposed to take a look at maybe GitHub too. I was supposed to look at, but we don't have much time again. So we'll have to call it today. So yeah, do you have any question, please? Any question?
No, none for now.
That means everything was very clear. Okay, yeah, so you can see the process that will take and the thinking pattern. So once you get this, once you get this thinking process, yeah, you're going to be able to solve many computational problems, a lot of them. So so the thinking pattern, the way you handle the problem from the start and you move to the end, yeah, that's really about is describing to the computer how to solve the problem. That's what we have done. So what we have done here, okay, let me just go back here. You see, this is just a description of the process. I say, okay, ask the user to get the height, make sure that the height is a number, print the top. So I just say print the top asterisk, like this, okay? And then here, we want to print out the horizontal, print the horizontal. So we want to print that horizontal line when we get to half of it. Okay. Otherwise, just keep on printing this and then this odd number. So it's one thing about programming that is good. All those maths you learned in secondary school, they are very, very useful. Okay. So always they are very, very useful in solving computational problems. So then that's one thing also I like about math programming is that most of the mathematics you studied, they are very, very, you will not see that they are very, very useful in real life. Like when we were growing up, they say, oh, this math, you will not use it. You will not use it, but they are very, very useful. In fact, when you go to data science, you're going to see that the maths you studied in your further maths, especially your further maths you did in secondary school, you can earn a lot of money just by understanding those fundamentals, like things like mapping, one-to-one mapping, things like regression, correlation. But for artificial intelligence, if you want to really know how to solve problems in artificial intelligence, you need to understand matrices. I'm talking about the matrices you did in school. Like you need to understand it. You can, by having that understanding, you can actually, gain a deep knowledge. Okay, and you now see that those maths can actually, all those things you learned before can actually, transform your life economically. So nothing is really wasted. Okay, so and again, if you are interested in learning in using those mathematics, if you are somebody that I know a lot of people used to like maths in those days, if you are somebody that used to like maths, it's an opportunity for you to go into data science and earn and make all those knowledge and earn something. Okay. So yeah, so this is the end of our class today. So if you don't have any question, yeah, we'll call it today. Your Python teacher will meet you next time, hopefully. Okay. And yeah, All right. Okay.
Thank you.
Yeah, no problem.
Thank you very much, sir. Thank you very much.
All right.
Hello, Mark.
Yeah,
Yeah,
Prince.
just wait.
Okay.
Yeah, I'll just hang around.
Okay. So I'm gonna stop the recording now. Okay.